Okay, so we're going to do a quick review on trig because that was a big part of the test last year, and also on algebra nation. The last two sections, I think it is also trig review. There's a part 1 and part 2. Remember, I'm giving extra credit for every time you take a test yourself and get 10% or 10%, 60% or better on. And I will give you extra credit on that all the way up until the day that your class does the test for part 1. Maybe even part 2, but not after that. Because after that, it doesn't really matter anymore because the test is over. Okay? So this may be a part 1 of the trig review for me. It may not. It just depends on how far we get. So if you will label your paper Trigonometry Review. For FSA. So y'all remember when we did the unit circle? Yeah, good. Make sure you can find every single part of the unit circle. You don't have to memorize it. If you do, you're gonna be able to find information a lot faster. But you don't have to, as long as you can find every part of the unit circle. You know the angle measures. You know how to convert them to radians, or how to convert radians to angles. You can find the ordered pair of every single place an angle intersects the unit circle. You need to be able to find all of that stuff. Okay, so we're not going to do the whole unit circle, but just kind of remind you. So I will try to draw a pretty circle with an X and Y axis. And remember, on the unit circle, the radius on a unit circle is 1. Right? So on a unit circle, if from here to here, if this X would have a value of 1 and the Y would have a value of 0. So that's easy ordered pair to find. At your 90-degree angle, that has an X value of 0 and a Y value of 1. At your 180-degree angle, your X is -1, your Y is 0. And at your 270-degree angle, your X is 0 and your Y is -1. Remember, if you start at the initial side and your terminal side goes counterclockwise, your angle is positive, right? But if you start at your initial side and your terminal side goes clockwise, you have a negative angle measure. So like this would be from here to here, that would have a negative degree. Okay, so that was initial side and terminal side. All right, so pretty much each of these, they're like in 30-degree, 45-degree, 60-degree angle increments. And then it goes that way the whole way around the circle. I mean, you could find any degree, but that's usually what you're going to see. So like this would be 30 degrees. Add another 15 degrees to get your 45-degree angle. Add another 15 degrees to get your 60-degree angle. And that's going to keep going all the way around. Then we're up to 90. Add another 30 degrees to get your 120-degree angle. Add another 15 degrees to get your 135-degree angle. Oops, I meant to put those down there. That 120 I meant to put down there. No big deal, but add another 15 degrees to get your 150-degree angle. So if you're starting down here and go up this way, that's 30 degrees, that's 45 degrees, that's 60 degrees, right? But counting from over here at 0 degrees, this would be 120, 135, 150. And then all the way over to a semicircle, that's 180 degrees, right? Straight line. And then you keep going, so 180 degrees, add another 30 to get your 210 degrees. Another 15 will get your 225 degrees. Another 15 to get your 240 degrees. And then another 30, you're at your 270 degree angle. And we'll keep going, so 270 degrees, 30 degrees over will be 300 degrees. 15 degrees over will be 315 degrees. Another 15 degrees, you're at 330 degrees. And of course, the whole way around, you're at 360 degrees. So your ordered pair for 0 degrees or 360 degrees is the same, because where that line, that radius intersects the circle is at the same ordered pair. Okay? So you also have to know, okay, well 30 degrees measured in radians. So the degrees measures the angle. Radians measures the arc, right? How many radii did it take if I lay on the arc? How many radii is from here to here? So that's what a radian is. So you're going to have to be able to convert your degrees to radians and vice versa. And we're not going to do it the whole way around. I'm just going to give you a quick little review. So to convert degrees to radians, you take the degree that you're given and you multiply by pi over 180 degrees. So if I want to know how many radians is 30 degrees, if I picked up this radius that has a length of 1 radii, and I laid it on a circle, how many of those would I get from here to here? Okay, so 30 degrees, so my degree is 30, and I'll put it over a 1 since it's a fraction, and multiply times pi, so it's 30 degrees times pi over 180 degrees. So you know when you multiply fractions, numerator times numerator, denominator times denominator. So you'll have 30 degrees pi over 180 degrees. So your degree symbols cancel. If you wrote 30 degrees divided by 80 degrees, the degree would cancel, right? And we could reduce 30 over 180 because 30 goes into 30 once, 30 goes into 180 6 times. So we'd have 1 pi left in the numerator, or just pi. And in the denominator, we would have 6. Don't put degrees, because the degrees canceled. So pi over 6 radians. 30 degrees is pi 6 radians. So was that one whole radius? No. It wasn't. So if we did 45 degrees again, 45 degrees over 1 times pi over 180 degrees. So that'd be 45 degrees pi over 180 degrees. The degrees would cancel. And I could reduce 45 and 180. 45 goes into 45 once. 45 goes into 180 4 times. So that would give me pi over 4 radians. Usually when you see pi, you know that's radians. If there's no degree symbol, you know it's radians, okay? So 45 degrees is pi fourths. 60 degrees. Multiply that would be 60 degrees pi over 180 degrees. Degrees cancels. 60 goes into 60 once, 60 goes into 183 times, so that would give us pi thirds radians. Now we know 180 degrees is pi, right? Because 180 times pi over 180, 180 is going to cancel. And we know a whole circle, 360 degrees, is how many pi? 2 pi, right? So 90 degrees is half of 1 pi, so that'd be pi halves. And 270 degrees, that's a whole pi plus a half, so 1.5 pi, but we don't want to write it as a mixed fraction, so 3/2 pi. And then, of course, we could find the radians all the way around. I'm not going to do that, but we could. Now, you need to know how to, also, if I'm giving you radians and I need to know the degrees, you need to know how to do that as well. And that's easy too. You're basically, instead of multiplying your radians times pi over 180, you're multiplying radians times 180 over pi. So you just flip this, okay? So if you need to convert radians to degrees, you take the radian measure that they gave you and you multiply that by 180 degrees over pi. So let's just check the one we have. We know 30 degrees is pi over 6. So let's see if we take pi over 6 and use our formula, if it'll turn it back into 30 degrees. So my radians is pi over 6 times 180 degrees over pi. So that gives me pi times 180 degrees over 6 pi. My pi's cancel, and 180 degrees divided by 6, now I have that little degree symbol now, is going to be 30 degrees. Let's try pi fourths. We already know that pi fourths radians is 45 degrees. Let's just try it real quick. So pi fourths radians times 180 degrees over pi. Now if we cross reduce, we know those pi's are going to cancel out, right? And 180 degrees divided by 4 is 45 degrees. You have to memorize these formulas for the FSA. I guarantee you they'll be on there. They'll have you questions of degrees to radians and radians to degrees. It's a standard. They're not going to give you these formulas on there, so you have to memorize them. They're not that difficult. Just remember, if you have radians, you have pi in the numerator. If you want to get rid of it, you need to have pi in the denominator. Well, pi is 180 degrees, right? 180 degrees is the same thing as pi radians. If you are given degrees, you want degrees to cancel, so you need your degrees in the denominator when you multiply, so that degrees divided by degrees will cancel, and pi in the numerator. So in that one, pi will be in the top, degrees will be in the bottom, 180. Okay? Everybody cool with that? Might as well go ahead and do pi thirds while we're at it. So my radians is pi thirds radians. Multiply it by 180 degrees over pi. We know pi's will cancel. You'll be left with 180 degrees divided by 3, which will give us 60 degrees. Okay, the other thing that we need to know how to find is the ordered pair of every angle on the unit circle. Okay? Remember SOHCAHTOA, sine, cosine, and tangent? Well, to find the ordered pair, you don't really need the tangent part, but I still write it out in SOHCAHTOA. To find the ordered pair on the unit circle, the ordered pair you find is cosine, comma, sine. So to find the ordered pair of 30 degrees, and I'll do this on the next page, I'll kind of draw a new circle. But I need to find the cosine of this 30-degree angle, and I need to find the sine of the 30-degree angle. Cosine is like your x, sine is like your y, right? Okay, let me do that on the next page. Little review, because you're going to be dealing with 30, 60, 90-degree triangles and 45, 45, 90-degree triangles on the unit circle. So you have to know how those side lengths, the relationship between the two. So if you have a 30, 60, 90-degree triangle, so remember, your 90-degree angle is always directly across from your hypotenuse. Your smallest angle in a 30, 60, 90, your smallest angle is going to be directly across from your smallest leg. And we refer to the smallest leg as x. So I always like to start at x and then figure out what the other sides are. Your 60-degree angle is always across from your middle side length, and that relationship between the smallest side, you take the smallest side and you multiply it by the square root of 3. Your hypotenuse is always the longest leg. It's always twice as long as the small side, so it's 2x. So if you know your small side, finding the other ones is easy. You can know any of the sides and figure out the length of the others, but if you have the smallest side, that's the easiest. So the other thing, the other kind of triangle that you're going to have to deal with in a unit circle is a 45, 45, 90. So of course, your 90-degree angle is always the two angles that form the 90-degree angle. What's the word I'm trying to say? Anyway, it's directly across from the hypotenuse. The other two angles are both 45 degrees. So the sides directly across from each of those angles are going to be equal because their angles are equal to each other. So those sides we call x. And if I want to know the length of the hypotenuse, I just take the length of the side and multiply it by the square root of 2. Right on? Perpendicular, that's what I was trying to say. Two sides that form a right angle, or when two lines cross, they form a right angle, they're perpendicular. Whew. All right, so let me show you how to find the ordered pair of some of the angles, cosine and sine. So I'm going to draw another quick circle so I don't cram everything in on the circle on the front page. We did this in our spirals for every single ordered pair on the unit circle. Do y'all remember that? So let's find the cosine and sine of our 30-degree angle. Cosine, comma, sine. So this is not a triangle that's in the circle, right? Two of the legs are straight and one is curved. A triangle does not have a curved leg. So remember, you need to go to the point where your angle, your terminal side meets the circle, and from that point drop a line straight down to the radius on the initial side. So I just made a right angle right there, right? So I know the side directly across from that is the hypotenuse. And this is 30 degrees. This angle must be 60 degrees. So if this side across from the smallest angle is x, because this is a 30, 60, 90, the hypotenuse is 2x, and the side across from the 60-degree angle is x square root of 3. So this is where knowing what SOHCAHTOA stands for helps us, because that helps me remember, okay, if I'm finding the sine, I do opposite over hypotenuse. If I'm finding the cosine, I do adjacent over hypotenuse. and I'm finding the tangent, I do opposite of over adjacent. Again, I don't really need tangent to find cosine and sine, but if we don't just do SOHCAHTOA, you know, I do SOHCAHTOA. But in future, you will need to know how to find tangent. So if I'm trying to find the cosine, I'm talking about the angle that is made from what we drew from the circle, okay? I'm not talking about these other ones. I'm finding the cosine of this 30-degree angle, all right? Whatever is the origin helps to make up, that's what I'm finding. So I want to find the cosine first. To find cosine, you do A stands for adjacent and H stands for hypotenuse. So to find the cosine of an angle, you take the adjacent side and you divide by the hypotenuse. Now, remember, two sides that make up an angle, they're both adjacent. But in this case, you're like, well, they're both adjacent. Which one do I pick? Whatever the side is the hypotenuse, it can't also be called adjacent. We just call it the hypotenuse. So if the 2x has to be the hypotenuse, then the other side will be the adjacent side. Right? So my x's will cancel, and I'll be left with the square root of 3 over 2. Remember, in quadrant 1, your x values are positive and your y values are positive. So this is like the x value of the ordered pair, the cosine is, so it's going to be positive square root of 3 over 2. When you do your math on all of these, they're not going to come up negative at all. You have to remember when's it negative, when's it positive. So remember, in quadrant 1, positive, positive. In quadrant 2, your x's are negative. This is just like if this was on a piece of graph paper, and your y values are positive. In quadrant 3, your x's are negative and your y's are negative. And in quadrant 4, your x's are positive and your y's are negative. Okay, we still have to find the sine of that angle. So sine, S stands for sine. Sine is opposite over hypotenuse. So the leg that's opposite of my 30-degree angle is x, and the hypotenuse is 2x. Your x's will cancel. Remember, there's still a 1 in the numerator. You can't just leave it blank. So you're left with 1/2. Sine is positive in quadrant 1, so there's my ordered pair. Coolio. And the whole thing done in one class. Let me do one more, and I'm going to do it in quadrant 3. I'm going to find the ordered pair of 225 degrees. I'm going to find the ordered pair of 225 degrees. Okay, if this is 180 degrees here, how many degrees did we go from 180 to 225? 45. So this angle right here that was formed is a 45-degree angle, right? So we know if we go to that point where the radius intersected the circle, this time our line we'll have to draw it straight up to hit like the x-axis, if you want to think about it that way, and make your 90-degree angle. So I'm no longer dealing with the 225-degree angle. I now made, if this is 45 and this is 90, I now made a 45-degree angle, right? So we know the two legs are x, and then in a 45, 45, 90, the hypotenuse is x square root 2. So I need to find cosine, comma, sine. If you do sine, comma, cosine, and you know all this stuff and you did all the work, it's wrong because it has to be cosine first. That's your x value. Sine is your y value. So to find cosine, I do adjacent over hypotenuse. We're talking about the 45-degree angle, where the angle that was formed by the origin. So adjacent, it can't be x square root of 2 because that's hypotenuse, and hypotenuse can't be both. So adjacent will have to be x. Hypotenuse is x square root 2. Your x's canceled, and then you're left with 1 over the square root of 2. Remember, you cannot have a radical in the denominator. It's like you can't leave a negative in the denominator. You can't do it. So you have to do what's called rationalizing the denominator. To get rid of the radical in the denominator, multiply your whole fraction by a new fraction, and you're going to multiply by whatever the denominator is above itself. So square root of 2 over the square root of 2. Because isn't the square root of 2 divided by the square root of 2 equal 1? And you multiply by 1, you don't change the meaning of the number. I may change the look when that's not actually 1, but I won't change the meaning. So 1 times the square root of 2 is the square root of 2. We know that the square root of 2 times the square root of 2 is the square root of 4. I still have a radical there, but what is the square root of 4? 2. And in the numerator, I can have a radical in the numerator. 2 is not a perfect square. It doesn't have any perfect square factors other than 1. So this is how I will leave my cosine. Because it's in quadrant 3, I know that all x values in quadrant 3 are negative. So I'll put negative square root of 2 over 2. Any questions on that? Then I'll just find my sine. Sine is opposite over hypotenuse. So the leg opposite of my 45-degree angle is x. My hypotenuse is x square root 2. Notice on this one, it's the same exact setup as the cosine was. Okay, that just on a 45-degree angle, because the opposite side and the adjacent side are both x, it's just going to work out that way. So we know x's will cancel. I'll be left with 1 over the square root of 2. We know, same thing we got up here, once we multiply by the square root of 2, we'll end up with square root of 2 over 2. All y values in quadrant 3 are negative, so that will be negative square root of 2 over 2. Again, I'm not asking you to memorize the unit circle. I'm asking that you know how to find each part of the unit circle. Okay, you can convert degrees to radians. You can convert radians to degrees. You know that it's set up in 30, 45, 60 degree angles. That you can find the cosine and sine. If you can do all of that, you'll be good to go on the trig, I think. Obviously, I don't write the test, but I'm pretty confident that you would. We actually did the trig on Algebra Nation. We did a packet, and we did that in class, I believe. So y'all should still have that packet. At the very least, go back and review that, and then take the little test yourself. So we got through part 1 and part 2. So there will not be another trig review video. That is it. Does anybody have any questions? Yes, pass those up. I will give you credit for them.